Hello, we're going today to explain a problem related to a velocity time curve. This is the curve we're going to use in our problem. Let's first, have a look at the curve. This is the time axis, this is the velocity axis, and at time equals 0, the velocity is equal minus 5 meters per second, and start to accelerate till it reach velocity equals 0 here, then start to change the direction and accelerating till this point start to decelerate and the speed is decreasing till it go back again to velocity equals 0. Now we'll start to look for the first part of the question. Said using this curve, there are 3 students make 3 claims. And let's look which one is right. We'll read each claim and then discuss it. At time t equals 0, we know the particle has 0 velocity because particles must start at rest. That's not right. Not every single particle start from rest. And actually in this curve, when you look here at the t equals 0, the velocity was equal minus 5 meters per second. So there is a velocity here. It's not from rest. So this one claim is wrong. The second student said, no, you are wrong. In fact, at time t equals 0, we know the particle is already moving in the negative direction. Let's see the claim. Yes, it's moving in the negative direction. How do we know that? Because the velocity is negative. Negative 5, negative 4, negative 3, so it is true. In fact, the particle is slowing down. Yes, it is slowing down. Why? Because, the speed here minus 5 meters per second. Then after that becomes minus 4 meters per second, minus 3 meters per second, and so on. So this one is right. The third student said, no, you are both wrong. At time t equals 0, the particle is speeding up. Is speeding up? How come speeding up? We know this because the slope is positive. That's true. The slope is positive because this is the direction of positive slope. But it's in the reverse direction. And the speed is negative. And as we said, it is slowing down, not increasing. It was minus 5 meters per second and then it reached 0. Okay? If we talk about speed, the speed only magnitude. So the magnitude is 5 meters per second. The magnitude is 4 meters per second. So the speed is decreasing. If we talk about velocity, it's something else. Because when you talk about velocity, you have to look for the sign, minus 5, minus 4 bigger than minus 5. But we're not talking about the velocity, we're talking about the speed. So, no, it's not speeding up. However, the slope is positive. So, this part of the statement is right, but this part is wrong. So, say the third student is wrong. So, the only claim is the second student. Let's move to the following part. Is the acceleration of the particle constant during this entire interval shown? How do you know this? Explain your answer. Well, we'll look at the curve and we'll see is it right or wrong. We'll just make a copy of this one and we'll go. Okay. Here I said, constant during the entire interval. No, it's not. Because of the entire interval from t equals 0 to t equals 3.6, it's changing. The acceleration here is positive, is accelerating. The acceleration here is negative. So it's not constant during the entire. So the answer is no. It's not constant during the entire interval. How do I know that? I know that from the slope. Slope is changing. Okay. Now look for part C. Said that's the equation x equal x naught plus v naught t plus 1/2 at squared. In principle, can we apply this equation to describe the entire interval? No. We cannot use it to explain the entire interval. Why? Simply because this equation only applicable for A is constant. When you use this equation, you plug number for A. You put 10, you put 5, so only you put one number. But here, what number are you going to use? The acceleration here is positive and here is negative. This different number. This one is not the same. So since, as we explained in part B, that the acceleration is not constant, so how come can you use this one? No, we cannot use this equation. Why? Because the acceleration is not constant. Okay, let's move to the next part. Part E, if there is a single instant in time, now it's not talking about dual interval, it's talking about single instant in time that corresponds to minimum position. Well, let's look at the curve. Yes, there is one instant where it's minimum. How do you know that? Well, how do you find the minimum position? The position is equal x. That's the position. To find the minimum or maximum of any variable, use calculus. You find the derivative and you make it equal 0. And this one may be maximum or may be minimum. We don't know. Very interesting. What's dx by dt? It's the velocity. So when velocity is equal 0, you can have maximum or minimum. Where is the maximum? Where is v equal 0 in this curve? You got 2 points. That's the first t. And how we calculate the time here? You observe that each 1 second is equal 5 square. 1, 2, 3, 4, 5 square. So if you have 5 squares equal to 1 second, it means 1 square is equal to 0.2 seconds. Okay, so the first time here, which is t1, 1, 2 and a half, so that will be equal to 0.5 seconds. And the last time here, 3, and you have how many square? 1, 2, 3 square, so be 3 seconds. So you got 2 times. V equals 0 at t1 equal to 0.5 seconds, and another time t2, which is equal to 3.6 seconds. Which one is corresponding to the maximum? Which one corresponding to the minimum? If you use calculus, we know that the second derivative test can tell you which one is maximum minimum. How we do that? You find the second derivative of the x and you look for its positive or negative. But you can write in different way. Why? Because the second derivative of x is like this is equal velocity, right? So when you find the derivative of dx by dt is like finding the first derivative of v. So this will be equal dv by dt. It's the same. The second derivative of the position is equal the first derivative of the velocity. Now this one has 2 possibilities. Maybe it is positive, maybe it's negative. When the second derivative is positive, the variable will be minimum, which is x. When the second derivative is negative, the variable is maximum. So how can you find the second derivative of x? By finding the first derivative of the velocity. How can you find the first derivative of the velocity? By drawing the slope here and there. The slope here is positive, the slope here is negative. So at t1 it is the x minimum. So we can say now at t1 equal 0.5 seconds, that's where you can find the minimum position. We explain this using calculus, and the same thing you can use physics. Okay, at t equals 0, the velocity was equal -5. It means it was moving in the negative direction or the reverse direction, and then was slowing down till it's going to the right position, and then it flipped to go on the right. So we'll say that was moving like that, Start by minus 5 meter per second, and then slowing till it reaches 0 meter per second, and then start to flip the direction and going, and even it reach here and start here, it doesn't change the direction. Negative acceleration here, or the negative slope, it means that the speed is slowing down but still in the same direction it reach here. So obviously if you put this as your reference, this is the minimum and this one is the maximum because far from the reference. So that's true. This is corresponding to the time when it flipped the first time, 0.5 second, and this one corresponding to 3 second. So it's the same answer. So at the time equal 0.5 second, you can find the minimum position. Let's move to part F. Estimate the acceleration of the particle at the instant corresponding to t equal 1 second. He wants to find the acceleration at t equal 1 second. Well, let's find the acceleration using the gradient. Here, the t equal 1. So at this point, you should make straight line and find the slope of this straight line. So the straight line, as you can see, it's coincide on the curve itself. So you'll move before 1 a little bit. So I'll choose this point and move to the right by 1 square and find the slope of this triangle. This one is equal 0.8 second. Why? Because this is 1 and each square is equal 0.2. So 1 minus 0.2 is 0.8. And then 1 plus 0.2, so you have 1.2 second. So that's 0.8 and it's equal to 3. And at 1.2 it's equal to 6. So the difference between this one is equal 3, 6 minus 3. And the difference between 1.2 and 1.8, why I'm doing this? Because the acceleration is equal dv by dt. But you can make it approximated dv by dt. And this is dv. And this is dt, which is equal 1.2.8. So dv is equal 6 minus 3. And dt is equal 1.2 minus 1.8. That's equal 3 over 0.2, which is equal to 30 over 4, 7.5, and the unit meter per second square. So that will be the approximation of the acceleration using the gradient or the derivative. Okay. Now we'll go to the next part of the problem. Okay, this is interesting. They are saying that they want to find the final position. We'll make it bigger, so we'll find the final position. To do the final position, I have to know the equation of the position. All what I know, the velocity is equal dx by dt. So it means dx multiplied by dt is equal v dt. To find x, I integrate both sides. You integrate dx from x naught to x final. You integrate the velocity over the time from t naught t final. So when you integrate this dx, you get x, substitute xf minus x naught. So xf minus x naught is equal the integration from t naught to tf, the velocity dt. And he said here x is equal 0 at t equals 0. What does it mean? It means x naught is equal 0. Accordingly, this one will be 0. So the answer, the final position will be equal the integration of t naught to tf v dt. So that's the equation for the position that they ask for. The problem now, how can I do the integration of this curve and I don't have the equation? Well, from calculus we know that the integration is equivalent to the area under the curve. So I'll say xf is equal the area for the curve vt. how can you find the area under the curve? You can just divide it into region. For example, this one area is a negative area. I can approximate as a triangle. I would just think it's a triangle, right? It's almost like a triangle. And I will look for the base of this triangle. How many squares? 1, 2.5, so it means 0.5. I will remind you again, every square is equal 0.2 second. And the height is 5. So what's the area of this triangle? Is equal 5, the height, times the base, which is equal 0.5 over 2. That will give us 1.25. 1.25. Now, but you have to remember, this is negative. This is negative area. It's minus 1.5. Now this one you can divide it to different areas, and I can do one, get answer. Somebody else maybe do another approximation, get different answer. It's okay, acceptable if the approximation is reasonable. So for me, I will just choose this point here and different color, and I make a line here. So I have line here, I have line here, and this one at 11. This is 11, and I connect from this one straight line. So, it's almost. So I try to find the area of this triangle. Well, here is 0.5, and you have 1, so the base is equal 1.5. And the height is 11, so the area of this triangle is 11 times 1.5 over 2. Okay, we'll just use the calculator to do it. You'll find it's equal 8.25, and the unit is meter, by the way, because you find displacement. And now the other one also, I will come at 11, across 11 I reach this point. You go down there and you connect this point by this point, so it's a straight line. So again, that will be like another triangle if we shade him. Okay, this is the triangle that I want to find its area. Okay, and this triangle, that's the base. This is 2.2.4.6, right? So this is 2.6, and this is the final by 3.6. If I subtract, it will be 1, and the height is 11, because at the same point 11. So 1 times 11 over 2 is equal 5.5 meter. So what's left? The triangle in the middle. Triangle in the middle, let's just do it. This triangle. Of course, is not, we're not going to get like the exact answer, but it's okay, it's approximation. It will not be very far from the right answer. So here the rectangle, and now let's calculate the area of this rectangle. From 2 to 0.6 is equal 0.6, so it's equal 0.6 times the height, which is 11, divided by 2. So you will have no, you don't divide by 2, because it's not triangle, it's a rectangle, so it's equal 6.6 meter. Now we got the whole area, so you add the whole area, this one plus this one plus this one minus this one. So let's do it. So the area is equal to 8.25 plus 6.6 plus 5.5 minus 1.25. You got 19.5 0.1 meter. That will be less than the actual area, but it's okay. So that will be the position. So the position in the end of the trip is equal to 19.1 meter. I hope you understood, and if you have any question, you can ask me. And please don't forget to subscribe for this channel. And thank you. And we're going to have more problem in physics to solve. Thank you, and have a good day.